This is recording. Yep, there we go. Yep, so we'll get started with everybody that's with people that have at least one person on from the team here, and then if the other members don't show up, then so be it. I can go first. Kartika and I, we inverter control systems. In terms of the control systems, we came up with preliminary design for connecting connecting the pre-charge circuit to the extremely low gauge, so high thickness wires that are coming out of the battery pack. So the design problem is, as some of you may know, the wires coming out of the battery pack are fairly thick, and the components, the electronic components related to the pre-charge circuit, have fairly small and thin wiring. And so we need to find a way to interface with thick wiring and bring that down to thin wiring. Kartika and I had a call, and we came up with some preliminary designs. I'm going to explore it a bit further, flesh out the details, things like that. But we do have a direction of where we want to go. Another project on the inverter control system side is we figuring out how to connect the AM seal connectors, the wires coming out of the AM seal connectors in the inverter, how we're going to feed that into the Arduino and the CAN bus and the various control systems that are on the pod. So we talked at some length about that. I think that's more or less finalized, and come October, our deadline, we'll have something ready to go. So that's everything on our end. Esther, do you want to go next? Talk about the charging system? Any updates?
Yeah, so Rayon and I and Kiki, we had a meeting last week to kind of clarify requirements. It was a very productive meeting. Essentially, I guess our plan going forward is that we are going to prioritize fast charging, safety, and cost effectiveness. And once we have achieved all of that for, say, a single module, we're going to hope to expand that for multiple modules, and also work to, I guess, automate the charging process so it requires minimal human supervision, because that's what we need going forward with, say, testing at another place. And we want to be able to just kind of have people plug into the wall and leave for lunch and come back, have it fully charged. So yeah, so we are still looking at different alternatives. So we could either go with like a already like off-the-shelf charger that's commercially available, or we could design something ourselves. So we're kind of look into both of that at the same time. And we have, I guess, like, we're pretty like inclined to design one ourselves, because from the looks of it, like, quality chargers pretty expensive, might not fit I guess, our budget. So yeah, but we're of course still looking into that and see if there's a way, say, using a dual channel charger, so one that charges two at the same time, could make it more cost effective. So this week I've been looking into charging circuits. So really they're circuits that I guess would usually be in like a charger, but then some people, like hobbyists, they have like homemade versions, and yeah, and you use a lot of ICs that already exist in a lot of commercial chargers. So I'm looking into those options. There are a lot of different ways to do it, and yeah. So that's my update.
I got a quick question regarding correct me if I'm wrong, but Kiki, he told me. I mean, this was a while back, so obviously plans will have changed since then. So I just wanted to get it kind of be brought up to speed on that. But Kiki said that he bought a balance charger and a power supply, and I think one other thing, I can't remember what, but he bought those two things. So
Yeah.
how, like, in terms of
How does
charging,
that? Yeah.
yeah, is that still
Yeah.
being integrated? Or are we still kind of going in that direction, or are you guys looking at alternatives at the same time?
Yeah, so this is one of the things that we clarified in the meeting. I thought that once Kiki's purchased those things and means that we're going with that, but um, so his idea is that we should experiment with different methods and find one that works best for us. So although he's purchased a power supply and like a small like balance charger, we're still looking into different alternatives at the same time.
Okay, got it. I tried to capture some of what you said on the OneNote, but um, I think it's better if you do that because you've obviously been to the meeting, you know what's going on. So, um, as always, just write down your updates in the OneNote and for others to see.
Yeah, Kiki actually asked me to prepare like a short, like one slide presentation.
Oh, okay.
All the other, um, I guess the basics of charging with batteries. I'm not sure if he wanted me to present this week because he's not here, and there's not a lot of people here. And, if you guys are interested.
I mean, yeah, you can show it. It's fairly short, right? So we can just go through it. Yeah. Um, yeah. So just share your screen and just walk us through.
So, essentially, when we're charging lithium-ion batteries, it's straightforward. We need to first charge it at a constant current. This current value, we obviously have to do ourselves. Once we charge it to the full charge, this voltage, we will continue to charge at that voltage and slowly drop the current down until it's fully charged. So as you can see in this diagram here, can you see my cursor by the way?
Yep.
So really, you should never be discharging a battery down to like 2.5 volts. So this is just for illustration purposes. But as you can see here, we have constant. Um, this is the current curve. So this is so you charge at a constant current while the voltage slowly rises up, and once the voltage reaches this point at this diagram, in this diagram is 4.1, drop the current down. And the reason that we need to do that is because there's something called the equivalent series resistance (ESR) in battery. So when you at this point right here between the transition from constant current and constant voltage, you see that, oh, my battery is already at 4.1 volts, it should be fully charged. No, it's not, because there's this equivalent series resistance here, and the voltage that you see, the 4.1 volts, is actually across both this resistance and the actual voltage of the battery. So in order to fully charge this voltage, here, you have to continue by at that constant voltage while dropping the current as you go. And in the end here, you can see that there's this little slope right here. And so this is actually just because if we leave the battery on its own, it discharges. And once it drops to a certain point, if it's still connected to charger, it will supply kind of the top up charge, gives the current, and you see the voltage rising back up again. So this is like, I guess, the basics of CCCV. There's also balance versus bulk charging. So when you're charging multiple cells connected in parallel, um, theoretically we know that branches in parallel connections, each branch should have the same voltage, but in real life that's not the situation, um, and so each cell is going to have a slightly different voltage. That's what I'm saying, and that's not good, because if a cell has a lower voltage and the other branches in the series, it kind of drags all the other cells down to that voltage. It tries to. So then it just doesn't. It's not good for us because we want it to all be fully charged as fast as possible. So that's there's something called balance charging, which is kind of like I guess, yeah, the process of kind of equating the voltage throughout the charging process. So then the difference of voltage difference between parallelly connected cells don't ever get too big. Um, so that's balance charging. There's something also called bulk charging, which is, you just don't care. You just fire them up in parallel, and then you just charge it. So yeah, so those are the two, I guess, different types of charging. Um, so fast charging. Fast charging refers to charging at I guess like a very, I guess, maximum current of maximum discharge slash charge current of the battery module. So I just have like a little formula for C rate, so you know what it is. So usually if you charge it at once, it you should be able to have it fully charged in an hour, because the capacity is the current multiplied current that the battery can supply, multiply like every hour. So if you divide by that, you get, I guess, the charge time. Usually, I guess, I guess for at least for older lithium-ion batteries, like it's not advised to charge at 1C because it's really fast and it might cause damage to cells, and you only want to do it um, if you're really time constrained. And but I guess for our batteries, they're a bit better, and we're our I guess one of our top priorities is fast charging. So we are planning to do fast charge as fast as we can. And also I have like a little note here about the role of BMS versus the role of charger. As I mentioned before, about balance charging, our BMS on our, I think, is it high? Yeah, in our HV module, I think it's like the top balancing BMS, which means it regulates the voltage across parallel batteries by chopping off like the chopping off the voltage of the cells that's overcharged compared to the other cells. So yes, the BMS does that, and because the BMS has this top balancing feature, we can actually couple it with a bulk charging charger to achieve like a balanced charging. Of course, it would be best to get a balanced charger and balancing BMS, but because we could still go with bulk charging because we have top balancing BMS. The thing is, the BMS does not replace the charger. Why? Because, as I said, we need this constant current, constant voltage charge profile, and that's just something you don't. If you just plug it into a power supply, it's just constant voltage. You don't get constant current first, and then constant current first and constant voltage, and like we know there's like a limit current I guess, yeah, current protection over current protection on the BMS. But that should really kind of be like a last resort to prevent it from going in fire. It shouldn't be something that you rely on regularly for charging. That's what the charger is for. And so I mentioned all of the design objectives before, and some of the considerations that's nice to have could be, say, going from this transition from CC to CV. If it's a smooth transition, then we don't risk damage to the batteries and the top of charge. Which probably doesn't really apply to us because we are hoping to have it fully charged and then and have it to go. But it's something to consider later on. And that's it.
Awesome.
Yeah. Sorry, I think that went a little bit longer than I expected. But
No.
if you have
That's
any
all right.
questions, please feel free to ask.
Yeah, and you know what I'm going to say, right? Just link this in the OneNote because this is some really good information. I'm sure a lot of people who are interested will benefit from it.
Yeah, I'll do that right now.
Awesome. So that's great. You guys are on track. Sounds good to see. Next up, in the interest of time, we'll just move on to low voltage battery design. Harsh, do you have any updates for us?
I'm still waiting on my uncle to add the sensors and the Arduino to the design that I showed yet last week.
Mm-hmm.
Also, I'm a little like I just realized I'm not that confident in my CADing skills because I really don't know assembly. So I will need someone's help later on to CAD the battery.
Okay. Yeah. Okay. Just message the sub. See if anybody is free and can help out.
Yeah, sure.
Yeah. I would offer my help, but yeah, when it comes to assembly, I'll use them as a last resort. We'll put it at that. If nobody responds, I can definitely hop on and give it a look. But when it
Yeah.
comes to assembly, that's not my forte. I'm more of the designing part, and then I send off the assembly to other people to do. But yeah, use me as a last resort.
Okay, sure. Thanks.
Yeah, but any general CADing questions, send my way. I'll try to answer them the best I can.
All right. Thank you.
Okay, so I think in terms of updates, that's about it. Bit of a shame that turnout was a bit low, but that's all right. It's partly my fault. I didn't put out the invitation in advance. But anyway, um, is there anything else that you want to say, Sarah, from your end?
Just that like we now have like a proper procedure. Like we got this little package emailed from the university, and so hopefully you guys will have access to the rooms soon.
That's
So
good
yeah,
to
it's
hear.
good news.
Yeah, we can finally. I don't even know what half you guys look like, honestly. Like, I've seen Carter K through video chats and stuff, but like and Sarah, but I don't know what half the team looks like. I've never met them. Yeah, so it would be nice to at least see you guys socially distanced, but see you guys and yeah, that'd be fun.
Yeah, that's so true.
Um, but yeah, it's Sunday. We'll end this early. 21 minutes. That's a record-breaking time. We'll end this early and let you guys enjoy your Sunday.
Yeah. Bye guys.
Bye bye. Take care.
Bye.